All right, so this is the first class of session 3. I'm going to prepare you guys for silver, but in the first 2 sessions, I prepare you all for the bronze competition, and we think we should be good on bronze, and then let me just share my screen and show my slides. So we wanted to review some of the complexity. Okay, so let me come back here. So complexity. So we just wanted to review this because put it that way, if you are doing bronze, usually you really do not need to worry about the complexity because the number is very small. Also, the algorithm is not that important. As long as you can finish it, use brute force should be fine because it's bronze and the number is not big. Even you use a very complex algorithm, it should be okay. It will get it done within time. But let's just come back to review this. So what is the O notation, right? So mathematical formulas that just calculate an answer, that's O1. A competition can never build O1, right? So that's what you will remember. So O1 is the simplest, the least complex algorithm solution. Then O log n, that's the binary search. Okay, that's usually also not achievable. It's very efficient if you do the binary search. Do you still remember which search is better than the binary search? Do you still remember? How many search we did? Linear search, right? Binary search, jump search, induction search, exponential search, right? So which one is more efficient than binary search? Do you guys remember? It's the interpolation. Actually, it's the exponential search. Okay, so that one is better than the binary search, and hopefully you still remember the algorithm, the formula. How do you do that? So then is the this one is also log n. Okay, the complexity is ordered set map or priority queue. So it is this operation. So that's the complexity if you wanted to order the sets. Okay, so that is the log n O notation or log n. So it's not complicated at all. So then is n square. So this is also very good. So you see, I ordered them by complexity from the simplest to the most difficult one, okay, most complex one. So prime factorization of an integer or checking the primary or compositeness of an integer naively. So that is the square root of n. That's the complexity, okay? And then what is the n? O(n)? Usually you do like a linear search, it's O(n), right? You loop through n items, that's O(n). When the n size increase, the complexity increase, but that's a linear relationship. So even if you get to this, it's also very good if your code written in that way, it's good. But also, like you see, iterating through an array or list of elements. So that's what I just mentioned. Okay. But this one, now it's getting a little bit complicated, but it's still acceptable. So it's O n times log n. Usually, like sorting, it's like that. For default sorting algorithm, like a merge sort, collection sort, array sort. So it's still acceptable. It's good. And this one now, usually it's hard. It's what you are trying to avoid. It's n squared. Okay, it's Java quick sort, array sort function on primitives. So that is n squared. Okay, it's already get hard, and you may not be able to finish it. Depends on how big the number is. So it's now the power of k. So iterating through all subset of size k of the input elements. So that is an nk. For example, iterating through all triplets is in power of 3. Power of 3. So that means in the triplets, okay, you want to iterate it. You take every 3 out from a list, and you loop through it. So that's the triplets, okay? So then 2's power of n, that is very complicated, right? So you want to iterate through all subsets, all kinds of subsets, okay? So that is the 2's power of n. And this one is the most complex one. It's called permutation. Permutation. The most complicated one, right? So this is the table you need to remember. So roughly the table at the right side provides the algorithm complexity you can go within the given time with the provided input size. So you don't need to think, okay, your computer is powerful and it can handle a very big number. No, because you submit that code to USACO. USACO uses server to run your code. So it's really how fast that server is. And you see, if you are getting into like n's power of 3, n's cube, if the n number get into 400, then you may not be able to solve it quickly enough, right? You see this one, 400. If your algorithm gets a cube of n, so what is cube of n? One example just showed in my slide is that if you, let's say you have 1,000 numbers and you took 3 numbers out, and then what was the possibilities? So all different 3s, right? That's the cube. So if you get into log n, so then you see the number can be very big. 10's 18 power, right? The power of 18. So that's very big. All right, so let's go to the most complicated example, permutation. Permutation, to understand why a factorial complexity is very time consuming, let's look at 2 things, okay? let's look at two things. We have a total 10 digits, 0, 1, 2, and up to 9, right? And you will have 1 billion possibilities to make a number of 10 digits. 10 billion. Is 10 billion the number big or not? It's a very big number, right? 1 billion, 1 billion, 10 digits. So if you want to take it, you want to create a number of 10 digits, there are 1 billion possibilities to do that. 1 billion possibilities. So if you wanted to try, let me put this number here. Put this website here. Can you guys go there and then read this website? So let me go to that website. All right. So let's go to the integer. What is the biggest number for an integer in Java you can get? If you use then 32-bit computer, that's the biggest number you can store in Java for an integer. So how big is it? So let me get in calculator. Let's see how big that is. I need a math scientific one, okay? So let's use this one. 2. Okay, so then what is y? All right, let me do this. How do I use this one? Can you guys teach me?
So what are you trying to do again?
Whose power of 32?
To press the X to the power of Y button.
This one?
No, go on the opposite side of the calculator in the same row.
This one?
Yeah. Like that. Oh no, it's because you're doing 0. Okay, so type 2 first. Type 2.
Mm-hmm.
Do X to the power of Y again.
This one?
Yeah, and then type 32. Remember that enter. Right? That's weird. Can you clear your calculator?
How do I create this one?
CE.
CE, okay.
Okay,
All right.
now do the same thing again. So do 2 first. Yep. Clear. You can't have 0 start out. Click it again. Yeah, okay. First type in 2
2.
to the power, and then 32.
Okay. So how big is this one? It's about 4 billion, right? That's the 4 billion. So the biggest number you can store in Java for integer for a 32-bit machine is 4 billion. So then you say, if you wanted to get like a 10 numbers of 1 billion, so it's a very big number. All right. So if I go to this one, so the biggest integer that Java stores is a 64-bit number. That is to the power of 63. So it can be got from maximum value attribute of the long class. It is a 19-digit number. Okay, 19-digit number. So I want you guys to find the value of the 22 factorial. Of factorial of 22. Do you guys know how to do that?
You want like the value?
Yeah.
So you want the value of 22 factorial.
Yeah. I want the value of 2 factorial. How big is it? What is the number?
I mean, it's big enough where it becomes scientific. It uses scientific notation. It's like 1
Scientific
point.
cannot do that, right? Can it do it?
I mean, no, it's in scientific notation. It's just that it's too big to display. It's
Yeah.
like 1.12 times 10 to the power of 21.
So you see that, so you will see the permutation. It's really, really complexity because if you wanted to get like the factorial value of 22, it's already go beyond the number that can be stored for an integer in a 64-bit computer. It's really too big. And 22 permutation, okay, factorial permutation. So that's already a number you cannot reach if you use your computer try to calculate it. Okay, you try to calculate, do that kind of computing. It's very, very complicated. So that is why permutation is the most complicated one. All right, most complicated one. So let me see. Let me just do this. How big is this one? Okay. $23. X equal to 1. X okay. So now let me print out the X. What is the X value? Value not handled. So it gives me this value. Okay. So let me use like 20, then you will see the value can be printed out. No. All right. I'm just wait. So this will be the number. So it is really very, very big. Okay. It's very big. So, okay, this will be thousand, million, and then a billion. Okay. Do you see how big the number is? Right. So the permutation is really very complicated. If you get into a permutation situation, and you cannot have a bigger number there. If you have a bigger number, you see that will be the complexity. So I hope you guys understand this. So now let's just go to the solutions to permutation. So I really want you guys come to do this problem. So let me get the problem for you guys. Where's the problem I have? So when you guys doing this problem, and let me put this also in so you can have it. So then we can talk about the solutions. And then I think this problem itself should be really easy for you guys. When you read this, and let's talk about how can we solve this problem. So you have a solution, right? Do we have a solution? Okay. So can you talk about what's the approach?
So you can approach it because it doesn't or it doesn't when it doesn't specify when it just says buttercup must be milk beside Bella, so you could buttercup just has to be above Bella. It can be or it's the other way around, but it can be Bella can be anywhere, but it just needs to be on top of buttercup. So basically you just need to come up with uh like a basic order, then you're able to find the one that has the lowest alphabetically things.
Mm-hmm. Look, what do you think? Exactly. So Stephanie, did you hear what Luke talking about?
No.
So then, if you do not, then do you have a solution for it?
Could you start with the names in order, and then once you get the input, then move the first name next to the second name after searching.
Okay. So Eddie,
Yes.
you have a solution. What is your thought?
Well, I mean, you could just kind of approach this like a math problem. Essentially, you can take the alphabetically lowest person because there's the first person, and then kind of just start going through the combinations because there's only seven at most seven conditions, so you can essentially just limit your options uh by whoever is you put first. Like for example, if you were to put Buttercup first, you can only put Bella in this case. So that's and then after Bella you can put uh sorry, and then after that you could put Blue or Buttercup again and just keep going like that. And then and then yeah.
Okay. So I wanted to explain this problem a little bit, the solution to you all. So you have 8 calls, right? So the all combination of the 8 calls is a permutation. It is a permutation of those 8 calls, right? You put them out one by one, order them. So that is a permutation. And let's come back, okay, do this. So if I see this 9, okay, so let me run it. So look at the screen. It's a very small number. It's only like 40,000 possibilities there. Only has 40,000 possibilities there. So you have plenty of time to loop through this 40,000. So number one, you need to build this permutation or it costs. Build this permutation, and now you loop through all the permutations one by one, okay, one by one to check these conditions, see who satisfied. And if it doesn't satisfy, just remove it. And you get all satisfied left. And then if you already sorted your stuff, you already sorted all the combinations, then you keep the first one. And that's the answer, right? And you will have a lot of things that satisfy the constraints. That will satisfy the constraints. And you just keep the alphabetical order one, okay? The lowest. So this is clear to you, Stephanie.
Yeah, so would you like have them in like a list then?
Yeah, that's a very good question. So how can I get the permutation? And actually, that is the focus of my today's content. All right, so let's come back to the slides. So how can you get the permutation? So getting the permutation is very time-consuming. There are many ways to do it. We will spend some efforts on its solution. The first one, of course, is a brute force algorithm. So use a recursive function. It will help us understanding this. So what is the recursive function? You start it, pick one item from the array and place it in the first position. Okay. And then perform permutation from that. And then continue this n-1 recursion until one item left. And then repeat step 1, 2, and 3. Okay. Until all items have been placed in the first position once. Okay. So what does it mean? Does this make sense to you? Pick one. Let's say you have 8 calls. You pick one call, put it in the first. Now it's the rest. Okay. n-1. n-1. How many possibilities? 7. All right. You try to put it into the second position. So you have choices of 7. And then you have 6 left. Now you need to pick one for the third position. How many? 6 possibilities. So that's why you keep doing this, and then you get all your permutation out. That's a list of all the possibilities. Okay, all the possibilities. So I just showed you, if you do that, this will be the number. You will get 40,320 possibilities for all the calls. So I'm not sure, Stephanie, this diagram makes sense to you? The steps. Let me do in a notebook.
But wouldn't you just keep like creating like lists, but each time you use like cow 1 and then cow 2, cow 3?
Yeah, let me show you, okay? Oh, come on. All right, so let's say I have 8 numbers. Okay, these are 7 numbers I have. I will do the first one. The first one, I will put 0, okay? And then the second position, how many possibilities? It will be 1, 0, 1, 0, 2, right? 0, 3. So keep going on. And now if I put these 2, and now I need to get the number for the third position. How many left? It can be 2, okay? And then it can be, but keep going this way, you will get a complete list of every combination. And when you reach this to, let me just finish this, okay? 3, 4, 5, 6, 7. So when you finish all those, all right? So now you need to start from now 1 get to the fourth position. So 1, 0, right? 1, 2. So that will be the way for you to loop through it. So you will get total like 40,320 possibilities. So you have a list of 40,302 or 320 items in your list. Then you pull that to check all these conditions. The maximum condition is 7, right? You just check if they satisfy each one or not. If it does not satisfy, remove it from the list. And then you have all the ones that satisfy left. If you already sorted the list before, and then you just need to pick the first one because the alphabetical order, right? Does that make sense? Stephanie, do you have a question?
Yeah, that makes sense.
How about you, Evan? Eddie?
Yeah, that works.
But what? I wanted to hear the part after the but. Okay, so let me continue on my slide. So this, I'm not going to ask you guys to do this because I think that should be easier for you guys to get all the 40,000 something. This is my Java code, okay? This is my Java code to print the permutation. You just try to use the strings, okay? You see, this is a string for I to 0, I less than the string length I plus plus. So you will get the characters out, okay? And then just to do all the permutations. That's how you do that. That's how you do that. Okay, so this is a one way to do it. Okay, you are trying to pull them one by one and order them, and then you get all the permutations. And there's another way to do it. There's another way to do this. So what is the other way? So this will really lead us to an algorithm. So you insert the nth item in all possible positions of a permutation of the n minus 1 item. So what does it mean? So I want you guys to look at the diagram I have on my next slide. Okay, so this is my slide. You see, if you only have one number, that's it, 1. So now if you have 2 numbers, you put the second number in all possible positions. So 2, that means you before it or afterward, right? Before it or after it. So that's why you say you get 2 items here. Now you have the third item. If you have the third item, now you will put that number in all the possible positions. So that's what you get here. 1, 2, 3. 1, 2, 3, right? When the 2-digit number, there are 3 possible positions. So you make it to like a 3 different numbers. And plus that one, you get 6, right? And if you have 4 numbers, then you have 4 positions. Then you will create 4 numbers, and then for every one. 4 numbers here, 4 numbers here, 4 numbers here, 4 numbers here, and 4 numbers here, and 4 numbers here. So then how many do you have? Tell me. If I have 4 numbers, what's the all possibilities of a permutation? Look at this screen. How many? It will be
8.
24, right? Because each one, like 1, 2, 3, it will generate 4 different numbers. Then 1, 3, 2 will generate 4. And you have a total 6 at that line. So then now the answer is 24. So you keep that going if you have 8 calls, okay? So you get to 9/8. You have like 40,320 possibilities there. So you get all those 40,320, and you can solve the problem, right? This is a permutation. This is a permutation, okay? And as I said, now I'm preparing you guys for the theory competition. So algorithm now comes to play, and it's very important when you do algorithm, okay? And I also mentioned it in the past. You solve a problem, it doesn't show a big achievement at all. But if you can improve the algorithm, that will be in the PhD level achievement, the PhD level achievement. I see that. So let's get to this website. So this is another algorithm specifically for this. Okay, so I want you guys to understand this one. So let me copy this one. So now I'm starting talking about the algorithm. You learn, improve in the algorithm, you will at least get a PhD, or you may be very famous in the world, more than a PhD. Okay, very famous. Look at this. Look at this. This algorithm is called a heaps algorithm. So what is it used for? It is specifically created for you to create permutations. Okay. So it was published in 1963. And this is an optimized way to generate a permutation. Okay. And it was proved. And in 1977, not long ago, okay, 1977, they reviewed this one, the algorithm, and then they concluded that is the most efficient way to generate a permutation in computer. Okay? Can you guys read this? And then specifically read this code, okay? And can you make sense out of it? I just give you guys the URL. What? Yeah, you don't need to care about the language. This actually is pseudocode. It's not of any language. It's just explain to you how to do it. But I tell you, now when we talk about algorithm, and this algorithm is called heaps algorithm. It's most effective and approved. You do not have another way better than this. And I want you guys to read this. Does it make sense? Does it make sense to you? You guys need to, I will give this as an assignment to you guys. You need to read this one. And if you do not understand this, so I can give you another document to read, okay? Come here, read this one. This is an explanation to understand what is Heap's algorithm. What is Heap's algorithm, okay? So let me put this in the chat as well. So I want to have both URL. And then I want you to tell me, okay, if you use Heap's algorithm, every one of you need to write your code. Use Heap's algorithm to get the permutation of those attack calls. And then tell me how many iterations you went through to get the permutation of attack calls. And then I already did that for you. If you wanted to do it using the recursive way, the iterations of 40,320. And I want to print out how many iterations you have when you use Heap's algorithm. And you see how much it saves us. How much it saves us. Okay? So then you just, increase it. Let's say now you get 10 calls. Then 10 calls use my recursive function. You will see how many possibilities you will have. Then you use the Heap's algorithm. You will see how many iterations you got. Okay? So can you guys read this Heap algorithm first? Can you make sense out of it? All right. So give you guys 5 minutes. Finish reading up to here, to this code. And tell me why this works. Why this works. If it works, then you need to write it in your Python and you need to save it just in case when you get into silver contest and you need to use this, you can easily get it. You can easily get it, okay? So you will see, okay, a lot of the algorithms are actually someone's PhD dissertation, or like a scientist, their research result. They spend a lot of efforts to do this. There is no Nobel Prize for math, no Nobel Prize for computer, but if you can have a breakthrough in the algorithm, I guarantee you are very famous, okay? It's not just you solve one problem of USACO. So remember, when you see the heaps algorithm, let's say you have 8 calls, whatever, you just put 8 calls in the list. So that's one combination. And then you just swap the positions and you get all the possible order, So that's how heaps algorithm handles that. Okay, it's not like what I'm using is from n-1 and n-1. Right? So that kind of strategy, this kind of strategy is also very famous. It is called a decrease and conquer. So after this week, probably sometime later in this session, I will talk about the divided and conquer. So heaps algorithm is decrease and conquer. Okay, decrease, you are trying to solve a complicated problem using a simplified one. So you do not know the answer for n, but if you know the answer for n-1, then you will know the answer for n. So you're trying to solve it that way, going from the number n to number 1 or number 0. So you are decreasing and you're trying to conquer it. All right. So I will give you guys this as the homework. You come back to explain to me why heaps algorithm work. Make sense out of it. And I already give you this document, okay? If you read this, you do not understand it, read this one. This already explained to you in a very detail, okay? And then you need to come back to me next week, use your own word, okay? I'm trying to do online class next week. I'm not here. I'm not in town next week. I hope I can do it online. If I cannot, I will let you guys know, okay? But the first thing I will ask you, I will pick any one of you to explain to me what is heaps algorithm and why it works. Why it covers all the possibilities. Why? All right, that's what I have. And do you guys have any question? Any question? Eddie?
No, I'm good.
You're good?
Yeah.
Okay. So Stephanie, are you good?
Yeah, I think I might need to take more of a look at the heaps algorithm.
Yeah. So I give you have both links, right?
Yeah.
This link is really, a walkthrough and why heap algorithm works. So make you understand that. And I just need you guys to explain to me in your own words why it works. And this one is just to show you. And you guys really need to have this code. Okay, you need this code in the Python, save it just in case you need to use it when you get into the competition. Okay, you get what I said, right? Ivan, you get what I said? Luke, you get what I said? How about you, Stephanie?
Yeah.
Okay, go back and read
Austin
this.
is a new student. Austin, you missed the second session. If you have any questions, just put the question in the Google Classroom, and the recording for this class will be posted as well. Okay.
Okay. So Austin, I think maybe this is hard to you because you missed